Okay, so are you taking the advanced BGCSE also, or are you just taking the paper version 1 and 2?
Um, I'm taking the advance as well.
Oh, you are taking the advanced. Okay, good. All right. So what I'm gonna do is basically for the first couple of sessions here, I'm going to go and solve a few exams, past exams, the full exams for you guys, and then in between or afterwards, we can then dig down deeper into what your weak points are, and then basically erase some of your weak points. So, for example, in the advanced session, okay, the other person is here too. Let me admit them. Okay, so yes, as I was explaining that what we're going to do is we're going to solve a few past exams, and you guys are going to have copies of each of these exams, and you're also going to have copies of these recordings that I'm going to do. So basically, the idea is that I'm going to solve a few exams, and then after we solve a few exams, there's going to be topics that you're probably not going to be familiar with or that you have trouble with. And those topics, we will then go over more detailed explanations in terms of how to solve those type of problems. And as I was explaining a few seconds ago, was an example may be, for example, in the advanced section, you may have a lot of problems on matrices, doing different matrix operations, and so that might be a weak point. Doing transformation of matrices, inverse of matrices, and those types of problems. Then we will dig down deeper into those type of problems. So here's an example of a actual exam. This is paper one from back in 2014. Another key thing that I wanted to highlight here is that if you notice, you have an hour and a half to solve. And this is the key part with national taking standardized tests and standardized exams, is that your time constraint. You don't have forever to solve these problems. You may be able to figure out the problems eventually if you spend some time, but you do not have time. You don't have a lot of time. So ideally, you want to be able to be familiar with the exam to a point where you know what type of problems they're going to ask you, and you can just dive right into it and just solve the problems. So you have an hour and a half, and you have roughly about 50 problems, if I'm not mistaken, for the first section. And out of those, this is paper two. Let's see. I actually get 20. So that's actually pretty good, actually. You should have no problems with an hour and a half to solving 20 problems. So anyway, this is the first paper. You're going to get a copy. We're going to email you a copy of this paper, this actual paper, and a copy of this recording. But you could take notes if you wish. But again, everything is already notes already taken for you, and you can just basically have a copy of this stuff. So let's look at this first question from this paper here. The Also, another thing to remember with exams, they usually start off easy, and then they get a lot more challenging as the exams go forward. At any point in time, too, if there's any questions that you just chime in, unmute, chime in, and just say, hey, stop. Just ask whatever question you have if you need some clarification in terms of what's going on. So the first problem says, we have a triangular numbers. Follow the pattern as shown. Write down the next two triangular numbers. So in here, if you look, you can see a pattern that's going on here. We have 1, 3, 6, and 10. Okay, so 1, 3, 6, and 10. So the question is, okay, I'm starting off with 1. How do I get to 3? All right, what did I have to do to get to 3? Well, you added 2 to get 3. Okay, so you have now 3. Then the next pattern, the next number was 6. What did I do to get to 6? Then you added 3. Okay, and then you added to get to 10, you added 4, and then to get to the next two, you since you see this pattern, 2, 3, 4, 5, you're adding 1 each time, and that's how you figure out what the next pattern is for the next two. Okay, so it's pretty much not basically a mathematical formula. Well, there is a mathematical formula that you can use, but that's a little bit beyond the scope of what you guys are studying. But you can just look at it and see the pattern. Okay, and then and that's how you would solve it. So what I would do with these types of problems, I would write down the information that you have: 1, 3, 6, and 10, just like how I did right here. 1, 3, 6, and 10. Then I would ask myself, what did I do, or what can I do to get to the next number? And there's only a few options. Either you can multiply by a number, or you can add a number, or you could subtract a number. And that's the process that you go through. And in this case, you just add. You add in 2. Then the next pattern, you're adding 3 to get to 6. You add in 4, and then you see the pattern says 2, 3, 4, 5, and therefore 6. And it can go on and on, 7, 8, 9, and you add that number to your original number that you have. So that's how you would solve a problem like that. And here you have number 2. The prime number 17, when its digits are reversed, is also a prime number. List 3 other prime numbers less than 50 that have this property, have the same property. So the question now is, you first must understand, like, what is a prime number? Okay, so you know a prime number is a number that only can be divided by itself in 1, right? So there aren't that many prime numbers. And so here, if you're looking at 2-digit prime numbers less than 50, well, you can go up the list and first of all figure out what are the prime numbers that are less than 50. So here you start off with 11, and you keep on going up: 13, 19, 31. But the question now becomes, when the digits are reversed, are they also primed? So that's the key part that you have to always think about in your mind, is that if I reverse the digits, are those numbers prime also? So if you look at these two numbers here, if I reverse 13, I get 31. If I reverse 19, I get 91. All right, and then you can see that if I reverse the 31, I get 13 again. And then you ask yourself, is that prime? And the answer is yes. And so those are the type of rationale you have to think about in terms of solving this type of problem. If you look at number 3, number 3 is pretty straightforward and simple. Convert 0.36 to a fraction in lowest terms. When you're converting a decimal to a fraction, what you have to do is you have to convert this decimal into a whole number. So how do I convert this into a whole number? I move this decimal place 2 digits to the right until I get the whole number, or you remove it X amount of digits to the right until I get a particular whole number. So in this case, if I move this decimal place 2 digits to the right, I get 36. In mathematics, if I move this digit to the right 2 spots, I have to divide by 2 positions also. Okay, so in this case here, so you divide 2 positions, will give you 100. So you move it to the right 2, then you divide by 100. Now we're not finished yet, because now you have 36 over 100. But the question now becomes, okay, I have to reduce this into its lowest form. Usually they always ask you to reduce anything to its lowest terms. So in order to reduce this to its lowest terms, what do I do? Well, I have to find a number that can be divided both into 36 and into 100. And what I usually do, I usually teach the fact that you start off with a small number, usually two, either two or three. You start off with a two or three, and then you keep on dividing. But in this case, we can clearly see that 4 can work, because we know that 4, because it's easy multiplication here, 4 can go into 36 9 times, and then we know 4 can go into 125 times. So that's pretty simple and straightforward. But usually I would start off, if it's a large number, I would start off with a 2 to see if 2 can go into both numbers. If 2 can't work, then I go to a 3. In that case, you would catch your even numbers and you would catch your odd numbers, and therefore then you would reduce. So in this case, 36 divided into 4 gives you 9, and then 100 into 4 gives you 25. At this point here, you ask yourself, well, can I reduce this any further? And the answer is no, because there's no number that can go into both 9 and 25 evenly. Because 3 can go into 9, yes, but 3 cannot go into 25. So that's what you, and so therefore your answer would be 9 over 25. This problem here, 17.5% to a decimal. So anytime we're talking about percentage, when we have a percent sign here, that means it's over 100. Okay, so 17.5% is 17.5 over 100. Okay, so therefore, if I'm going to convert this into a decimal, therefore I divide 17.5 over 100. And then when you divide by 100, or when you're dividing decimals by tens or hundreds, however many zeros you have to move your decimal point to the left by the amount of zeros you have. So in this case, we have 2 zeros. So you just move it to the left twice. 1, 2, right here, and you get 0.175. Okay, so that's how you would convert that type of problem. Okay, now when you have a fraction and you're converting a fraction to a percentage, in this case, you have to multiply by 100. Okay, so you have to multiply by 100 in this case. So always remember, if I have a decimal, if I have a percentage and I want to convert that to a decimal, I divide by 100. But if I have a fraction or a decimal and I want to convert that into a percentage, I multiply. You do the opposite operation. So in this case, for this one, I have 13 over 20 multiplied by 100. Okay, and so therefore I have, I think you can use calculators in the exam, but I've showed you the long way also, just in case, so you could really know how to work these problems. But you could just put this in your calculator, 13 over 20 times 100, and you can get your answer. But if you multiply the top, you'll get 1300, and you divide the bottom, you get 20. So here, 20 over 1300. So how do I solve this? Well, the first thing I ask myself is, I'm dealing with 20. 20 divided by 1300. Well, I don't know. I can't figure that right out in my mind, but I can pretty much figure out 20 into 130. So right here, 20 into 130. So 6 times 2 is 12. So 20 times 6 is 120. So therefore 130 minus 120, and that becomes 10. And then you bring down your 0. So now you have 100. And then 20 into 100 gives you 5. So that's how you can calculate this the long way. And that would be 65%. All right. This problem, complete the diagram so that it's symmetrical about the x and the y axes. So when you have a problem like this, you want to just calculate symmetry about the x and y. So if I'm looking at the x-axis, that's this axis right here. Okay, so therefore I want to reflect this diagram, this angle, or this I guess you could say this line, I want to reflect that over the x-axis, what do? Well, I am how many points, how many units away from the origin? 1, 2, 3. Let me see, did I do this one? No, I didn't do this one here. I think I was trying to talk about this one. So 1, 2, 3. 1, 2, 3. So therefore, 1, 2, 3 units would be in terms of from the origin. And I'm reflecting this over the x-axis here. So I'm going over this direction, not this direction here, not the y, just reflecting it over the x. So 1, 2, 3, 1, 2, 3. Okay, so now I ask myself, how many units away from the x-axis do I have right here? Just 1 unit away. So therefore, I go 1 unit away up here. And then how many across? 1, 2, 3 across. So 1 up, 1, 2, and 3 across. And then remember, it was right here. So it would be a line right here. Next time I'm going to use my tablet so you can see. I think I can annotate right here. Yeah. I can draw. Let me see here. So I go here. And then I go, we see 1, 2, 3, 1, 2, 1, 2, 3, here, go here, and then I come down here, something like that. Okay, and then you would do the exact same thing over on the y-axis here. Okay, so you would reflect that over on this side. Okay, and so this is how you would complete the symmetry of this type of problem. Okay, so over on this side here, you would go 1, 2, 3 across. So 1, 2, 3 across. So we go right here, and then we go 1 down. So we go 1 down right here, and then therefore we are 1, 2, 3, of course, across. 1, 2, 3 across here. Okay, and therefore I can then go do it like that. Okay, so something like that. Okay, and so this is how you would draw the diagram in terms of the symmetrical about the both axes. Okay, let me clear this. Get this. Okay, so now I got to. Okay, hold on. Okay, all drawings. All right. So simplification. There's a order of operations that you have to remember when you're dealing with simplification. And what is that? Well, you have to do, first of all, powers first. Okay, all exponents, depends on how you say it. Then you do parentheses, or the brackets, and then you do multiplication and division from left to right. And then you do addition and subtraction from left to right. So the first thing you would do here is you look and see I have a parenthesis here. The first thing I would do is evaluate that parenthesis. Okay, 9 minus 4. So 9 minus 4 gives me 5. Okay, now what I want to do is I want to evaluate my multiplications. But I evaluate it from what? Left to right, right? From left to right. So therefore I have 5 times 3 gives me 15 right here. So I've completed this operation right here. So now I have 7 plus 15 times 6. Okay. Well, I still have to do multiplication from left to right. Okay. So therefore this multiplication has to be evaluated next. Okay. So 15 times 6, that gives me 90. And then I add my 7, gives you 97. Okay. So this is pretty straightforward. So these first 5 problems shouldn't give you too much difficulty. Okay. So now let's see if you're going to get any more difficult problems as we go forward. And I think it's going to get a little bit more challenging, but not that much. But usually the first few problems is pretty much easy to get you warmed up. All right, so from the set S above, write down the factors of 48. All right, so what factors do we have of 48 here? And this is pretty much straightforward also. We don't have that many factors. I don't think I did that one. Did I did it 6? Yeah, I didn't do A because A was pretty straightforward. So in this case, I only see one factor, right? Which is this one, and well, these two, right? 8 and 16, right? Because 8 times what can give you 48, right? 8 times 6, okay? And then there's 16 times 3. So these is a factor of 48 here, these two. And then from B, the multiples of 3. So here, what numbers can we use to, when we have multiples of 3, what numbers are here in this set? I think I did this one. Yeah. So here we have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. And in this case, we look up here, we only have, looks like only 15, right? So that's the only one that we have here, okay, that we can use. Okay, so let's look at 7. Okay, so 7, you have to be careful on this one. Just make sure you read the information really carefully, because this can really trip you up if you're not careful. The Labor Day men's marathon began at 8:45 a.m. Jack finished the marathon at 11:10. Calculate in hours and minutes the time taken to run the course. So the way I would approach it, I would just approach it in terms of 1 unit at a time. So we want hours and minutes. So let's just deal with hours first, and then we can calculate the minutes. So he's starting off at 8 a.m. and he's finishing at 11. So right there, that's how many hours? That's 3 hours. Okay, so we have 8, 9, 10, 11. He starts off then at 8:45, and we want to get to 11:10. Okay, so how many minutes would that be? Well, 15 minutes will give me 9. Okay, and then we have 10 minutes after 11. So therefore, 15 and 10 gives you 25. Therefore, it will be 3 hours and 25 minutes. Okay, so that's how you would solve a problem like that. It's pretty straightforward. This one is a little bit more challenging. The Labor Day Women's Marathon began at 9:30 a.m. Sue took 2 2/3 of an hour, or 2 2/3 hours to finish the marathon. Calculate the time she finished the marathon. Okay, so for this problem, we need to know what is 2 2/3 of an hour is. What is that in terms of an hour? Okay, so once we know that, then we can really solve this problem, because we know what 2 hours is. 2 hours is 2 hours. So if she started at 9:30, for example, and she finished in 2 hours, then we know that she finished at 11:30. But what is 2/3 of an hour? Well, we know that an hour is 60 minutes. Okay, so therefore 2/3 of an hour basically means that you calculate 2/3 times 60, and that will give you the amount of minutes that 2/3 is in terms of an hour. Okay, so just do that multiplication. 60 times 2 is 120. 120 divided by 3 gives you 40 minutes. So in this case, so she took 2 hours and 40 minutes. So therefore, if you add 9:30 to 2 hours, that's 11:30. and then you add 40 minutes to 11:30, you have what? 30 minutes give you 12 o'clock, and then 10 more minutes gives you 12:10, which will be 40 minutes. So therefore, she will finish at 12:10. Okay. All right, so just about almost halfway done with this first exam. Adam, Bill, and Corey spent the day fishing. Adam caught F fish. Bill caught 3 times as many fish as Adam. Corey caught 7 less fish than Adam. Okay, anytime you're having these word problems, what you want to do is you want to write down each statement in terms of a mathematical formulation. Okay, so each statement. So for example, we have Adam caught F fish, right? So Adam caught F fish, so right here. That's the first statement. Second statement, Bill caught 3 times as many fish as Adam. So if you look at Bill, Bill caught 3 times F. Okay. Corey caught 7 less fish than Adam. So we go to Adam. Remember, Adam is F fish. So therefore, Corey caught F fish minus 7, because it said here 7 less fish than Adam. So now, we've written down all of our statements. Now we can go ahead and answer the questions. So the first question is the number of fish caught by Bill. So we know that Bill caught 3 times F, so therefore the number of fish caught by Bill is 3F. We can't put no numbers in here yet because they haven't given us a total amount of fish that was caught. Okay, so if they had given us some totals, then we could have put numbers. But in this case, we just have to put mathematical expressions. The number of fish that Corey caught, I think we did that already, right? So Corey caught F minus 7, okay? The total number of fish caught, given your answer in the simplest form. So Adam, Bill, and Corey, all right, went fishing. Adam caught F fish, so therefore the total amount of fish is going to be F fish plus Bill's fish, 3F, plus Corey's fish, F minus 7. So in this case, you just add like terms together, and that's how you solve your expression. So in this case, it'll be F plus 3F, 4F, plus another F, which is 5F. So therefore, 5F minus 7 will give you the total amount of fish. Okay. So that's how you would solve these word problems. So the technique would be you write down each of your expressions and then basically just answer whatever questions they have. Knowing the algebraic expressions in terms of adding like terms together, making sure that you subtract properly, making sure that you add properly, and then you should have no problems with these types of problems. Okay, here we have a Venn diagram. The Venn diagram shows the sets M and N contained in the universal set E. Okay. List the elements in the set M union N. So basically, we just want all the elements in M along with all the elements in N. So in this case, it'll be what this P, R, S, and then T and Q. Okay. I don't think I did because that was so simple. I didn't calculate that one. So P, R, S, T, Q. That's M and N. Okay, so that's what you would put there. So now the question is M intersection N. Is there any elements that's in both M and N? And the answer would be no. So this would be the null set. So I would write a 0 here and a line through it because there's no intersection between M and N. Okay. N prime. So everything out of N. Okay, so everything out of N. So everything out of N will be the elements in M, which is this P, R, and S, and also anything in the universal set that's in here. So in this case, you have V. So these four will be N prime. Okay. So here, what's this? The number of elements in M. So here we'll have three elements. The number of elements in the intersection of M prime, N prime. So what's not an M and not an N? Not an M, not an N. So we have one element, which is just this V. Okay, and this one here, you're gonna have to, I guess, use a protractor to solve. So you just line your protractor up right here to find the angle O, which would be this angle right here. And you're gonna have to just, that one you have to just do with a protractor and see what it is. And again, use your ruler and the length of PQ. You're going to have to just get your ruler and just measure PQ on the paper and then write your answer down. Okay. And then same thing with this one, leaving all construction lines, use a pencil, ruler, and a pair of compass to bisect angle OPQ. So OPQ, that's this angle right here. This angle, you want to bisect this angle right here with a compass and protractor. So again, this is something that you're going to have to just manually do on the paper. And you're not going to have too many. I think I saw one problem like this over each exam. You're just going to have one where you do this kinds of thing on the paper. One or two at the most. Okay. You're going to see a lot of these types of problems. So this is what I would try to get used to and to make sure that I understand on how to solve these types of problems, because this is consistent from what I've seen on the exams. So here we have Eric works at the ACME company. His incomplete statement of earnings for last week is shown below. Calculate and complete his earnings statement. All right, so here we have regular hours, 40 hours times 1260. So in this case, you just multiply 40 times 1260. And I think I did that right. This is another one. Yeah, I didn't do this because it's simple. So 40 times 1260. I would complete that right here. I should have done this. Wait, well, let me see. That didn't come out. All right, so in this case, you basically get your calculators and just 40 times 1260. So that will give me 504. Okay. Yeah. That will give me 504. And then let me do this while we're here. 504. And then 8 hours for overtime times 1890. 151.2. So his gross wages will be 151.2 plus 504. So we get 655.22. 655.2 and 20 cents. That's his gross wages. So then we have to calculate his deductions. So we have national insurance, union dues, and medical insurance. So we add those three up. So if you add those three up, you get 59.4. So and then in this case, you would just subtract 655.2 minus 59.4. And you get 595.8. It's just total wage. And that was it. And that's all you do for this problem. So this is hardly no calculations, just multiplication and subtraction and addition. So it's not difficult at all. But just understand what do we mean by 40 hours at $12.60 per hour. that means you have to multiply that, okay? Because you're getting paid $12 for every hour. So therefore you have to multiply. Okay, so 12, I think this is the one yeah. Okay, so a male manufacturing machine punches out 1 3/4 inch nails from a coil of wire. Okay. The length of coil needed to produce 240 nails, assuming there's no waste in production. So in this case, we know that the machine punches out 1 3/4 inch of nails from a coil of wire. All right, so one nail is 1 3/4 inch. So how long will it be? How long will the coil be needed to produce 240 nails? So therefore, you just simply multiply. Okay, so in this case, I converted 1 3/4 inch. I convert that into decimal. So we have 1.75, right? Because 3/4 is 0.75. Remember, 1/4 is 25 cents, 2/4 is 50 cents, 3/4 is 75 cents. So therefore, if I have 1 3/4 inches of a nail, I have 1.75 inches of nail. So I multiply 1.75 inches times 240 nails, because that's how much nails I'm going to be producing. And so the total length, when I multiply those two together, will give me 420 inches. Okay, so that's how you calculate part 1. Part B, the amount of nails that can be produced from a coil of length of 875 inches. So in this case, I have 875 inches, but what information am I given in the problem? It says that one nail takes 1 3/4 inch, or 1.75 inches. So if I have 875 inches, and I know that one nail takes 1.75 inches, if I divide the two, I will get the total amount of nails that's produced. Okay, so you get 875 divided by 1.75, and that will give me 500 nails. Okay, so that's how I would calculate that problem there. So the difference in length between 2.5 and 1 3/4. Okay, so in this case, I think I didn't do this one either. Should have solved this one here. Okay, so there's a couple ways to look at this. We can go and do this the long way, in terms of converting this improper fraction to a proper fraction, and then subtracting the two. That's one way. Or you can just look at it in terms of the whole numbers here, 2 and 1, right? 2 minus 1 gives me 1, right? 1/2 minus 3/4. Okay, so then in terms of a quarter, right? How much is a half in terms of a quarter? So in this case, a half is actually 2/4, right? So if you think of whole numbers, if you think of dollars and cents, we know that 25 cents and 25 cents gives me 50 cents. So 25 and 25 is 50, which means I have 2/4. 2/4 will give me 50. If I have 3/4, that gives me 75 cents, right? So then if I have 50 cents and I'm subtracting 75 cents from it, I don't have enough to get a whole number, right? So I'm going to be losing. Okay, so I'm having 50 cents and I'm taking away 75 cents. I'm going to be short a quarter. Okay, so if you look at it that way, you could say if I subtract a half and 3/4, I'm going to be owing a quarter. Well, what do I take that owing that quarter from? I take it from the 2 and the 1. So 2 minus 1 is 1, but I'm owing a quarter, so 1 minus a quarter gives me 75 cents. That's one way to look at it. If you don't understand these types of problems, these arithmetic problems, what I could do, I could set up the tablet tomorrow, and we can go over more and more drills on these fractions and converting fractions into whole numbers and just dealing with these subtractions and additions of these improper fractions, because I think these are very simple um, in terms of to calculate, because there's no thinking really involved, but you just have to know the process. So if you don't know the process, then it's just going to be a little bit more difficult. But once you practice and once we go over these multiplications and additions of improper fractions, then it'll become simple and become easy. So you guys just let me know if you need more help in those. I'll make a note right now to probably go over some of those tomorrow or whenever the next time we meet. Okay, so 13 here. So here we have a isosceles triangle, right? Because these two sides are equal. That's what this means. It's a 90-degree angle. And from this angle, from this triangle here, we can we know automatically what the angles inside here is because of what type of triangle it is. So this is a 30, 60, 90 degree triangle, and it's something that you will have to know. So there's no way of figuring out or getting away with getting around this. You're just gonna have to know your triangles. You're gonna have to know, for example, if I had another dashed line across here, that will be an equilateral triangle, meaning all angles are equal. So therefore, inside each triangle, I will have 60 degrees each. Each angle will be 60 degrees because it's an equilateral triangle. See, that's something that you have to know. So you can't figure that out. You just have to know that. And in this case, since only these two are equal, these two sides, and not the hypotenuse, it's a 30, 60. The smaller angle is always 30. The larger one is always 60. And then this one is always 90. Okay, so that's going to be 30, 60, 90 degrees. And always remember that the total angles inside a triangle always adds up to 180 degrees. Okay. All right. Same thing with this one here. There's certain information that we need to know when we're dealing with geometrical lines and quadrilaterals, meaning that I have four sides to shape to an object. Remember, the total amount of angles inside here is going to be 360 degrees. Anytime I have a straight line, the total amount of degrees I have here is going to be how much? 180 degrees. Okay, so that type of information we're going to have to know. Because these two lines here are parallel, all right, this angle here is equals to this angle right here, the x. So 37 and 37, those are equal. So these are the types of information we're going to have to be readily be aware of when we're looking at diagrams and triangles, etc. So, all right, so right here. So we have angle B. Automatically, we know that first B says angle X. So we know that's going to be 37 degrees. Okay, so that's easy, straightforward. Then they want us to find Y. So in this case, if we look at right here, we have 100, 180. Angle Y. Okay, right here. Okay, so this is 37. This is 37. Okay. Therefore, where am I this right here, because this parallel line right here. Okay, so let me put the annotations on here. Where's the, so you could see. Annotate. Okay, so because these are parallel here, right? This here, this line and this line is parallel, right? And they dissect, and this line dissects it. Therefore, this angle and this angle is the same. These two right here, those are the same. Okay, so therefore, if this angle here is 37, 180 degrees minus 37 will give you what the y is. Okay, so that's what you're going to have to know. And I don't know if they teach this, or if you go over in your geometry section for your courses, properties and these geometrical shapes and identities, but certain stuff you're just gonna have to know. So these two are equal, and these two are equal, the x and the 37. Okay, so therefore, let's see, part 2. Get this one. Let's see, I want to clear all annotations. Okay, so y, in this case, y is going to give you 143, okay, because you subtract that 37. Okay, so therefore, if I have 37, I got 143, and I got 93, okay? Question now is find angle z, which is this angle right here. Well, how do I find this angle z? If I knew what this angle in here is, I can figure out z, because I know that the total degrees in the straight line is going to be 180. Okay, so I can easily figure out what z is, 180 minus this internal angle right here. Well, I already know 3 of the 4 angles. I know 37, I already just calculated y, and I know that this is 93. So therefore, 143 plus 37 plus 93, that gives me 273. Okay, so to get this angle in here, I take 360 degrees minus 273, and therefore I get 87 degrees. All right, so this right here is 87 degrees. So if that's 87, what is z? Well, z is 180 minus 87. In this case, 180 minus 87. And that will give me 93 degrees. Okay? And so angle z is 93. So if you need to go over more of these diagrams and more of these types of problems, just make a note, and then at the end, just let me know what we need to cover again, so that y'all can get more proficient at solving these types of problems. Okay, so 14, given that z equals 9, w equals 13, calculate the value of z squared plus w over 4. This is pretty straightforward. Z squared, meaning that 9 times 9 gives me 81. I think I did this one here, yeah. Z squared, 9 squared is 81, plus w over 4. W is 13 over 4, and we just add those two together. Okay, and you could do that with your calculator. 81 plus 13 over 4. Okay. In part B, 14b, we have 7 times p minus 5 equals 21. This is simple basic algebra. This is not a complicated problem. You just distribute your 7 into your parentheses, first of all. So we'll get 7p minus 35 equals 21. Okay, so in this case, 7p minus 35 equals 21. Then you want to get the minus 35 to the other side of the equation. So we want to solve for your p. So in this case, you would get 7p is equals to 21 plus 35. 21 plus 35 equals to 56. So 7p equals 56. Therefore, p is equals to 56 over 7. And that's how you solve this problem. And of course, you were taught you can quickly check it. In this type of problem, we can quickly check. If you put 8 back into the original equation for p, 8 minus 5 gives you 3. 7 times 3 equals 21. 21 is equals to 21, so we know we're correct. Okay, so 15. Two business partners, Mr. Evans and Mrs. Fraser, share profits in a ratio of 5 to 6. The profits for this year were $26,400. Calculate Mr. Evans' share. So, out of a total amount of, if you're sharing in a ratio of 5 to 6, the total amount of units you have here is 11. Okay, and so therefore, the fraction for Mr. Evans would be 5 over 11. Mrs. Fraser would be 6 over 11. Okay, and so therefore, if you want to calculate Mr. Evans' share, you would use that fraction and you multiply by the amount of profits that were earned. So in this case, Evans would be 26,400 times 5 over 11. And when you multiply that, you get 12,000. Okay. Okay. Last year, Mrs. Fraser received 8,400 as her share. Calculate the total profits of last year. So this one is a little trickier. You're going to have to think about this one. This is almost like the reverse, right? The original problem gave us the total profits, and then we wanted to calculate the ratio. Well, calculate the share. In this case, we are given the share, and now you want to calculate what the profits were. So we know that Mrs. Evans is going to be the 6 part. So she's going to have 6 over 11. So 6 over 11 times total profits is equals to her share. So in this case, we're just solving for total profits. Okay, so I have, if I do 6 over 11 times total profits, this division of 11 here, I need to get rid of that and put it to the other side of the equation. So basically, I need to multiply both sides by 11. So I multiply this side by 11 to get rid of the 11, and I multiply that side by 11. So 8,400 times 11, 6 times total profits equals to 8,400 times 11. The next last step is define total profits, which means I have to just divide by 6. So I divide both sides by 6. So I have total profits is equals to 8,400 times 11 divided by 6. And total profits equals 15,400. And that's how you would solve that problem. So let's think about it again. In this case, we were given what the share was, and then we're asked to find what the total profits is. So it's the opposite. In terms of this problem, we were given what the profits were and asked to define what the share is. Okay, so that's the kind of thinking you have to do. With renovations to the business, Mr. Evans and Mrs. Fraser investments changed to $17,500 and $22,500 respectively. Calculate the ratio in terms of its lowest forms. So in this case, basically you're just dividing these two numbers together, and then you want to reduce it. Okay, so you write those as a quotient, okay, and then basically reduce it. So here you have the total amount is going to be 17,500 plus 22,500, which is 40,000. Okay, so Mr. Evans' share is 17,500 out of the 40,000 total. So this is the top part here, 17,500 out of the 40,000. You then try to reduce that. When you see a large number like this, I usually would think of using a large number. So what's the largest even number out of 17,500 and 40,000 that you think you can use? Well, I use 500. Okay, so I just did 500 divided into 17,500 because I know those can go into each other evenly, and I use 500 into 40,000. So therefore I got 35 over 80. And then I went ahead and reduced that. You divide that by what? 5. 35 into 5 gives me 7. And then 80 into 5 gives me 16. And then I can't reduce that any further. Then I calculate Frazier's portion. So he was 22,500 over 40,000. Again, I used the same methodology, divided by 500 by both sides, both numerator and denominator. So 522,500 gives me 45. And then 500 into 40,000 gives me 80. And then the exact same thing, 5 into 45, 9. And then, of course, we know 5 into 80 is 16. So 9/16. Okay. So therefore, the ratio is going to be 7 to 9. It's going to be the ratio. All right, for that problem. All right, 16 here. This one, did I solve this one? No. Yeah, I think we could have solved it right here, actually. Sugar is sold 3 types: powdered, granulated, cubed. It is also sold in 3 packages: small, medium, large. The table shows the type of number of packages sold. Complete the table. All right, so for this one, this is pretty straightforward. I think I could do the annotations for this one here. All right, I want to do pen. I want to draw right here. Okay, so if you look at powdered, small, medium, large, you already have all 3 already filled out for you. So basically add them together, right? And that now will give me what my total is for that powdered portion, 141, right? So let me see. No, this is not what I want. Clear. I want to do text. Yeah. Well, I guess I could do a box here. Yeah, so this is going to be 141 here. Okay, now look at the mathematics here. What am I missing right here? I'm missing a figure here. I know that the total is 400. So if I add this plus this plus this, should give me 400. So therefore 400 minus these 2 will give me the missing number here. Okay, so in this case, we will have 400 minus 120 minus 141, 139. So in this case, we'll have 139. Okay, and then I would just make sure double check everything right quick, because it's easy. Since it's just with a calculator, you can easily double check that, make sure that everything is aligning across the board. So just add these 2 together and make sure you get 400. So you see, and in this case here, I have 139, but I'm missing this 1 here. But if I subtract these 2, right, I should be able to get this inside number here. Okay, and this is exactly what I do. So I do 139 minus 45 minus 40. So it gives me 54. So just make sure you see this pattern in terms of what we're doing here. We're using the total to help out find the missing. So here we have a 35 as the total. We have these 2, and therefore we get this missing one. Right? So 135 minus 54 minus 26 gives me 55. So in this case, we're going to have 55 here. All right. Okay, and then again, look at this. We have everything here, 35, 50, and 45. So there's no subtracting. Plus 45. In this case, we have 130. Okay, 130. Make this. Oops. Hold on. Trying to get to the 130. It wouldn't let me get in there. But anyway, you know that it's 130. And therefore, we have here This last one, 135 minus 40 minus 80 will give us the internal one, right? Because these three added together gives you 135. So therefore I'm missing 1. So you just subtract 135 minus 40 minus 80. And this should give you 15 for this last one here. Alright, and that's that. And that's the diagram filled out. So this one is pretty straightforward. Just use the information that's given. Use the totals is the key for that one. Alright, so just get 3 more problems for this first test. Okay, I get to clear X out of this. Oh, I need to clear these annotations. Okay. All right. Okay, 3 more problems and we're going to be done. And this one's so 17. James purchased a sailboat for $23,000. Sorry. He paid a deposit of $5,000 and obtained a loan from the bank. Calculate the amount borrowed from the bank. So in this case, it's basically 23,000 minus 5,000, right? It shouldn't be too hard to calculate that, right? 23,000 minus 5,000, 18,000. So now the question is, he agreed to pay the loan in 3 years at the rate of 9.5% simple interest. Calculate the total amount repaid to the bank. This is what you're going to have to remember. In terms of loans and payments, interest is always going to be principal times the total interest paid is going to be principal times the rate times the time. Okay, so that's the simple interest formula. Principal times rate times the time. And that gives you the total amount of money paid. So they want to find out, calculate the total amount repaid to the bank. So you have to pay interest, plus you have to pay the principal. Because remember, the bank is lending you $18,000. And then they're charging you interest. So you not only pay back the principal, but you have to also pay back the interest. So first of all, let's calculate the interest, which is I did here. So we have 18,000 times 0.095% times 3, and that gives you 5130. So the total amount paid will be 18,000 plus 5130. Okay, so that's that. Now, James repaid the loan in equal monthly payments. Calculate his monthly payments. Okay, so we know that the total that he has to pay is 23,130. He has to pay that over 3-year period. Okay, and he has to pay it over equal month payments. So therefore, how many months are there in a year? There are 12 months in 1 year. Therefore, there are 36 months in 3 years. So therefore, we have 23,130 divided by 36. And that's how you get your answer. Okay, and that's that. So very simple, very straightforward. Okay. This one, 18. A window is in the shape of a square and 4 semicircles are shown. The square is of side 36 centimeters. So that's the square. Okay. Using 3.14 where necessary, calculate the area of the square section. Okay. We don't need, notice the key. Use 3.14, which is pi, where necessary. The area of the square section. We don't need 3.14. We don't need pi to calculate the area of a square. What's the area of the square? Length times width, right? So therefore, the area of this square is going to be 36 times 36. Okay? So that's that, 1296. Okay? So yeah, 1296 centimeters squared is the key, right? Because we're multiplying 36 centimeters times 36 centimeters. So you're going to get centimeters times centimeters. All right, so centimeters square. Okay, part B. The area of the semicircle section. Okay, this is the semicircle section, right? This is one semicircle section. How many of these semicircle sections we have? 1, 2, 3, 4. So I'm thinking, yeah, that's what they want. The total area of the semicircle sections, right? Which is these 4 sections here. We know the area of a circle, a full circle, pi r squared. Pi times radius squared. We know that a half a circle is going to be pi r squared divided by 2, because this is what we have here. We have a half of a circle here, not a full circle, a half, semicircle. So pi r squared divided by 2, which will be the area of this 1/2, but I have 4 of these. So if I multiply that by 4, I will get the total. So this is what we did here. So first of all, the area of one semicircle, pi r squared divided by 2. So pi, which is 3.14, times 18 squared. Where does 18 come from? 18 is your radius. This right here is your diameter. Half of the diameter is going to be 18, which is your radius. And that's what we use to calculate the area. We use the radius, not the diameter. That's why I divide that by 2. So therefore I get 3.14 times 18 squared divided by 2, and that will give you that. Okay, that's just one semicircle. Now I need to multiply that number by 4 to get me the area of all the circles. So once I get that answer, I multiply by 4 to get the area of everything, and that's what I did here. Okay, multiply by 4. Well, we need to find the total area. The area, well, the area of the semicircle section will just be that multiplied by 4, and then the total area of the window will be the semicircles plus the area of the inside. Okay, and that will be this semicircles plus the area of the inside. Okay, so that will be this one, 3,330.72 centimeters squared. All right, 2 more problems and we're done with this test. It's very simple. Simplify. Minus 7 times x, minus 7x. Minus 7 times a minus 5. Remember the rule, when you're multiplying two negatives gives you a positive, so you get positive 35. So it's minus 7x plus 35. Okay, that's that. Part B, you're adding like terms together. So we have a 9y plus 1y, which gives me 10y. 9y plus 1y, 10y. 5z minus 8. So a 5 minus 8 will give me a what? A minus 3. So it's 10y minus 3z. Okay, and that's this one right here. 10y minus 3z. Okay, and therefore C, this one, you're going to have to know the rules when you're dealing with exponents, when we're multiplying exponents. Anytime you have a power, when you're multiplying a power, you what? You add. Okay, the two powers. So a to the 3 multiplied by a to the 1 gives me a to the 4. And then you multiply the numbers, the coefficients on the outside. 9/10 times 2/3 going to give me what? 18 over 30. So in this case, we're going to have here 9/10 times 2/3 gives me 18 over 30. A to the 3 times a to the power of 1. Anything that just has a variable, that means it's raised to the power of 1, gives you a to the power of 4. And then in this case, you always have to reduce. So these two numbers here, you have to do reduce. So divide by 2, you get 9 over 15. Okay, and so that will be your answer for that one. And then we have D. It's going to be here. You're going to use division here. Again, the rule for powers, you need to know your rules. When you're dividing powers or exponents, you would subtract the powers. When you're multiplying exponents, you add the powers. So in this case, you're dividing, so you're going to have to subtract. So in this case here, 18 divided by 3, that gives me 6. B to the 6 divided by b to the 2 gives me b to the 6 minus 2, which is b to the 4. So therefore I have 6b to the 4. And the last problem here is, yeah, it's the last one. And this is going to be statistics. So 16 students were asked how many hours each studied for a final mathematics exam. Their responses were recorded below. These are the responses. Write down the mode. So what is the mode? Anytime we're dealing with mode is what number occurs the most. So the first thing you want to do anytime you do statistics problems like this, you want to rewrite those numbers in terms of the order that they're in. So from the lowest to the highest, that's how you want to rewrite it. So in this case, you have 4 zeros. Okay, 1, 2, 3, 4 zeros. Okay, and then you have 1, 1, and you just basically write down all the numbers in terms of higher order. Okay, that's the first thing you do. Then you ask yourself, which occurs the most? Well, we have 3 4s, 2 3s, 1 2, 1 1. We have 4 zeros, so 0 occurs the most. Okay, median. This is what you have to be careful of. This is why we need to rewrite the numbers in higher order, because in order to find the median, you need to find the middle number. So it has to be ordered first, and then we find the middle number. So we go what? 1 1 1 1, and you just basically come together, keep on coming together until you get the middle number. So here we're stopping here at 3 and 4. I can't come together because it's even. So therefore, what you do is you have to add these two numbers together. Okay. If I had another number in the middle here, let's say 2, or no, 3, another 3, for example, then I would cancel the 3 and the 4, and then my median would be 3. But in this case, there's no other number here. I have 3 and 4, so therefore I have to add those two together and divide by 2. And that's how you find your median in this case, and which will be 3.5. So the next question asks us, calculate the mean. The mean is basically the average. So I add everything up and I divide by the amount of data points that I have. Okay, so in this case, the mean will be 3.25. I add all these numbers up and then I divide by how many? 2, 4, 5, 6, 7, 8, 9, 10, 16. Okay, so 52 divided by 16, when you add all them up, it gives you 3.25. All right, so here are the last 3 questions. A student is selected at random from this group. Calculate the probability that the student did not study. So if I look at the diagram here, how many hours did how many students did not study? So I'm looking at the zeros. So I go back here. I have 4 students that did not study because they have zeros here. They didn't study at all. Out of a total of how many students? 16. So therefore, the probability will be 4 over 16, which reduces down to 1/4. So the chances of you picking a student out of this group that did not study is going to be 1 over 4. Studied 5 hours. So if we look at someone that studied 5 hours, we're going to have 2 students studied 5 hours. So it's going to be 2 over 16, which is 1 over 8. Okay, so it's pretty straightforward. And then part C is studied less than 5. So less than 5 will give me how many hours you'll be looking at. Not 5, less than 5. 4, 3, 2, 1, and 0. So we get how many people? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we get 11 out of 16 studied less than 5. Okay, and that's how you solve those problems. Okay, so this is actually test 1. So if you all were to encounter a test similar to that format, you should be able to get at least, I would say, 90 on that test, because nothing was really too hard. Maybe those angles, maybe, I don't know. You guys have to let me know which types of problems would give you all kind of difficulties, and then we can iron out the problems later on. So that's test 1. We'll finish that for today, and then the next time we will go over test 2. Now test 2 is a little bit harder. Let me see if they give y'all more time on these. I think, yeah, you get 30 extra minutes to do test 2. So this one is 2 hours. So therefore this is a little bit more involved in terms of the calculations, but we'll go over this next time, and we'll calculate everything. Yeah, you're gonna have a lot of diagrams, and yeah, a lot of calculations on this one. So this one is a little bit more complicated. So anyway, I'll leave it there for today. Any questions? Let me know if you have any questions now. If not, we'll meet next time and we'll cover test 2. And again, we're going to email you guys the links for this test and also for this recording. So you'll have this as a backup. And then also we're giving you guys some extra video tutorials too, some extra lectures on BGCSE problems and topics and etc. So you're going to have a lot of material to go over. But again, just encourage you just to take your time, go over the material. If there's anything that you don't know or you need more clarification of, because sometimes it just might be a simple rule that you don't know, and that will like throw you off for the whole problem, you know. So again, if there's something that you don't know, just let me know. And if there's no questions, then we'll meet next time.